minus 1. If you divide both sides by 2, you have x to the third minus 1 equals 0. So you have x to the third is equal to a positive 1. So to get rid of the third, if you cube both sides, you have that x is equal to 1. Now if you set the denominator to 0, you have x to the third equals 0. If you cube both sides, then you have x is equal to 0. So these are going to be our critical numbers. So we need to look at when x is 0 and when x is 1. So again, we have our intervals. Our test value. The sign of f prime. And then our conclusion. Alright, so if we do from negative infinity to 0, we can choose something like x equals negative 1. So if we look at the sign of f prime of negative 1, so f prime of negative 1 is going to be this 2 times negative the cube root of negative 1 minus 1 divided by the cube root of negative 1. Now here, cube root of negative 1 is just going to be negative 1. So 2 times negative 1 minus 1 over negative 1. That's going to be a minus 2. So that's minus 4 over minus 1, which is a positive 4. So f prime of negative 1 is positive. So our original function is increasing over this interval. If we look at from 0 to 1, we can choose something like x equals a half. We need to look at f prime of a half. So then f prime of a half is going to be 2 times the cube root of a half minus 1 over the cube root of a half. Well, let's see, we know that the denominator is positive. We know that this number is also positive and is also less than 1. So the cube root of this number, so some number less than 1 minus 1, this number should be negative. So this number should be negative. I must have done this with the other class. So this numerator is negative. So the whole thing is going to be negative. So f prime of a half is going to be negative. So our original function is going to be decreasing on this interval. And then if you look at 1 to infinity, you can choose a test number like x equals 2. Then if we look at f prime of 2, so f prime of 2 is going to be 2 times the cube root of 2 minus 1 divided by the cube root of 2. Okay, so if the cube root of 1 we know is 1, so since 2 is larger, that means the cube root of 2 is larger than 1. So something larger than 1 minus 1, this number should be positive. And this is positive, so you have a positive number over a positive number. So we know that f prime of 2 is positive. So this is positive. So our function should be increasing over the set. So since when x is 0, our function is increasing on the left and decreasing on the right, that means we have a relative maximum when x is 0. And since our function is decreasing on the left of 1 and increasing on the right of 1, we have a relative minimum at x equals 1. So there is a relative maximum at x equals 0, and there is a relative minimum at x equals 1. Okay. Alright, so we're going to stop there with 3.2 and we'll pick up next class for the next topic.